Hi, my name is Noah Ingman and I am Jacob's little brother. Today I'm going to tell you the ABCs of reservoir fluid properties and what it means to me. A is for AGP, additional gas produced, and this is what it means to me.
No, actually, AGP is related to the mass of a gas produced from the second separator and the stock tank for three stages of separation. AGP can be found from Figure 7-3 correlation in McCain.
Nah. B is for barrels, and this is why I love barrels.
Barrels are the units used to measure reservoir fluids that are produced, mainly oil and water.
C is for Celsius. It is currently 10 degrees Celsius. Brrr.
Hey, you nailed it, Noah. Celsius is used to measure reservoir and reservoir fluid temperatures.
D is for dew point. The air inside me is warm and the temperature out here is cold. So when I breathe, my air turns to water.
Very good, Noah. That's a good example. In a reservoir, if the temperature decreases, gas in that reservoir can therefore turn to liquid.
E is for EOR, enhanced oil recovery.
Nice, Noah. Steam injection specifically is one of the most prominent methods for enhancing the production of our reservoir fluids. Steam is typically used to produce heavier oils, heavy crude oils.
F is for flaring. I really wish this fire would light.
Hey, that's kind of close, Noah. Flaring, gas flaring specifically, is when you produce unwanted gas and you flare that gas to dispose of it instead of injecting it or transporting it.
G is for gallons. Right now, I'm about to start the gallon challenge. If you don't know what that is, that's when you drink a gallon of milk in an hour. Here we go.
Gallons is a typical unit used to measure reservoir fluids, especially oil and water, used in place of barrels sometimes.
Nah, I'd rather not puke. H is for horsepower hour. My dad's BMW has 300 of those.
Hey, you're kind of close, Noah, but horsepower hour in petroleum fluids refers to one of the universal gas constant's units of energy. That universal gas constant is 0.000788048.
I is for ice. There's enough ice on the ground for an ice skating rink.
You're close, Noah, but when I said ice, I meant more of methane ice or methane hydrates. Methane hydrates is a cage-like lattice of ice inside of which are trapped molecules of methane. When this ice is melted, the methane or natural gas can be produced.
J is for Jake. Jake is my older brother studying and teaching me about reservoir fluid properties.
I think that one pretty much nails it, Noah. Nice work.
K is for K sub J, or equilibrium ratio. If I stay in this freezer long enough, I will have an equilibrium temperature with the freezer.
Hey, it's not a bad example, Noah, but actually equilibrium ratio in regards to petroleum reservoir fluids is the composition of a gas divided by the composition of a liquid that exists at equilibrium at a given pressure and temperature.
L is for LBS, or pounds. Currently, I am 75 pounds. Been like that for 3 years.
Pounds in reservoir fluid properties is typically known as pound moles, which is equal to the mass in pounds of a gas over its molecular weight. Also, you can calculate the mass of that gas in pounds by multiplying the molecular weight times its pound moles.
M is for mu, which is viscosity. This jar of honey here has a very high viscosity.
You're right, Noah. Viscosity is a measure of the resistance to flow exerted by a fluid. That honey does have a very high viscosity, just like heavy crude oils might have. However, lighter oils and water are going to have a lot less of a viscosity, while gas has even less of a viscosity.
N is for Noah's favorite reservoir fluid property. Mine is bubble point.
The bubble point is the point at which the first few molecules leave a liquid and form a small bubble of gas. I'm really glad this hot tub isn't at bubble point because your face would no longer be your face.
O is for oil, and that's the reason that I can ride my dirt bike!
Hey, you're right, Noah. The oil is one of the most important producing reservoir fluids. Gives us the power to ride things like this, power our cars, other things like that.
Hi, P is for pressure. The more pressure you put on a piano key, the louder it is.
Very good, Noah. Pressure actually is typically used to describe reservoir pressure so you can understand what kind of conditions your reservoir fluids are in. But pressure is measured in pounds per square inch, and those keys are about 5 square inches. Therefore, the more pounds of pressure you put on them, the louder you're going to be able to play.
Q is for quadruple point. I like to call this the ultimate point.
You're right, Noah. That is the quadruple point, and the quadruple point is when 4 phases are in equilibrium: liquid water, hydrocarbon liquid, hydrocarbon gas, and solid hydrate.
R is for resistivity. This is what resistivity means to me.
Hey, that was kind of close, Noah, I guess. I don't know. I'm going to say resistivity with regards to petroleum reservoir fluids, though, is the conductivity of a brine solution. Water typically doesn't conduct electricity. However, water-containing dissolved salts will conduct electricity.
S is for solution solubility. We're going to mix all these substances and see which one is soluble in water.
Very good, Noah. You kind of nailed this one, actually. Solution and solubility kind of go well together. You can make a solution of different fluids, such as these fluids that don't really resemble the reservoir fluids, minus the water in the glass. However, doesn't look like a lot of these fluids are soluble in water. Soluble means that they're going to dissolve in the water and become a homogeneous mixture. It looks like you got a pretty heterogeneous mixture, which shows that these fluids aren't soluble in the solution of water.
T is for temperature. Currently, the temperature of the water in my bed is 95 degrees. Let's increase it to 100.
Hey, nice, Noah. T is for temperature. And temperature in reservoirs vary. Water is something you have to know the temperature of. Oil is something you know the temperature of. Temperature of your reservoir can help you understand what kind of conditions your reservoir fluids are in.
U is for undersaturated. When you fill this glass of water up, there are bubbles proving that there's a gas. And when you pop the bubbles, there is no more gas.
It's kind of close, Noah. Kind of close. Undersaturated reservoirs are reservoirs that contain solely liquid. If you had a saturated reservoir, you would have a solution such as the one you're poking right now that would have both liquid and gas in solution.
V is for velocity. We're going to see how fast I can run.
You're right, Noah. V is for velocity. V in reservoir fluid properties is typically used to measure the velocity of a fluid either in the reservoir, in the production casing, in the surface equipment, in the pipeline, or any other place the fluid will be flowing.
That was exhausting. W is for water. I'm so thirsty.
Hey, I bet you are thirsty after all that running. Water is one of the most important and critical reservoir fluids. Water affects the production and conditions of the other reservoir fluids such as oil and gas.
X is for X, which is the symbol for mole fraction. If I cut this mole in half, I'll have a fraction of a mole.
No, I think mole refers to more of the unit mole in this case. Mole fraction is the fraction of different components that make up a natural gas or a reservoir liquid.
Y is for our y-intercept. Look, I actually have homework on y-intercept that I'm supposed to be doing instead of this project.
Get working on that, Noah. Actually, yeah, it's a good one. Y-intercept In figure 3-7 of McCain represents a Z factor that is equal to 1, which would represent a gas that is ideal. Other figures in this book have y-intercepts that mean other information.
Z is for Z, which is the compressibility factor. I'm going to try and compress this ping pong ball.
Hey, you got the compress part right at least, Noah. But compressibility factor, or Z factor, is defined as the ratio of the volume actually occupied by a gas at a given pressure and temperature to the volume the gas would occupy at the same pressure and temperature if it behaved like an ideal gas. How's it coming over here? Oh, there it is.
I got it.
Compressed.